All right, so on to homework 6, and in this case, problem 55 on page 79, which is a sister to your two assigned problems 51 and 53. And all three of those problems, you're given a function. I've traced down the example from 55 here, and you're asked to find all of the absolute and local maxima and minima. So in order to do this problem, you really just have to remember the difference between these two things. A local max or min is the largest or smallest. Value on an open interval. And an absolute max or min is the largest or smallest value on a closed interval. That's a little bit of a informal definition, but let's go look at the implications associated with open and closed intervals. So if we look at local max or mins here, remember those are effectively points that are at the tops of hills or at the bottom of valleys, if you will, on graphs of functions. And in this case, that would appear to be the point 3, 2 and the point -1, -3. But that open circle indicates that that point's not there. That is, the function does not have a value at the point x is equal to 3. This would be the point 3, 2, or it is the point 3, 2. However, the point 3, 2 is not part of the function's range. Likewise, this point here, where x is equal to -2, would have a value of -2, but the open circle indicates it's not there. So these 2 points, which otherwise, were they part of the function's range, would be the local max and local minimum, or not. So there are no local extrema here. Just to hit that point home, let's come over here and say what the domain of this function is. The domain is all the points between -2 and 4, with a closed interval, because the function includes the point -2, -2, and it includes the point 4, 1. So the domain is -2 to 4. The range, however, the range goes as low as -3, but does not include -3. And it goes as high as +2, but it doesn't include +2. So the range is an open interval in this case. And because of that, there's no local extrema. And likewise, if we start to look now for the absolute largest value, you find that there is no largest value. Again, if this was a point on the curve, the largest value over the entire domain would be 2, and the absolute maximum would be 2, but that point doesn't exist. So there's no absolute maximum. And by the same argument, if indeed this point was on the curve, the absolute minimum, the smallest value on the whole domain, would be -3, occurring at x equals -2. But that's not part of the story here, so there's also no absolute extremum. And that's the answer to problem 55 here.